So now we're going over up on schedule.
Good evening, stargazers. We're sorry about the intro video didn't work, but we've got people all over the country and indeed in other parts of the world willing to show you what they've got on their telescopes. In fact, funnily enough, we've got clearer skies in Britain than in Spain at the moment. So certainly in the south of Spain, there's terrible thunderstorms. But fortunately, we've got other people around in Spain as well. So we've got a good program lined up. Now, as you know, all the planets are in the sky at the moment, and we've got lined up for you Venus. We can't do Saturn, it's a bit too low at the moment. We've got Venus, which you've all seen, I'm sure, over in the western sky after sunset. And we've got the moon, which is there as well. We've got Jupiter, which is really high up at the moment and is a wonderful sight high up in the south. And we've got Mars, the red planet, which is looking really red right now. So we really, you can't mistake that if you go out and have a look. If you want to know where they all are, I'll take a look at the National Astronomy Week website, where you'll be told how to find them. And there's even a video showing you which planet is which and how to find them. But to start with, we're going to go over to David Arditi, who is in Wedgware, and he's had clear nights every night so far of National Astronomy Week, and he's got the planet Venus through his quite large telescope, and it's let's have a look at that. It's a wonderful sight. Over to you, David.
Yes, good evening, Robin. And I'm sitting in my warm room next to my observatory, housing a 14-inch telescope, and I'm looking, as you can now see, at the image of the crescent Venus through the 14-inch telescope. This is a color camera, and so you'll see some false color around the edge of Venus. The false color is due to our atmosphere. It refracts different colors differently, and that's why you've got an edge, a colored edge to Venus. And all the movement is due to the fact that Venus is low down in the sky. It's about 30 degrees high, so it's shining through a few hundred miles of our atmosphere, all at different layers, at different temperatures, at different refractive indices, causing turbulence. So that's what we see when we look at Venus in the evening. But it is tremendously bright at the moment. It's quite close to the Earth. It's only 75 million kilometers from the Earth, or half an astronomical unit, and it's getting closer, it's getting bigger every night, and the phase is shrinking night by night, a phenomenon which incidentally was first noted by Galileo in 1609, I think it was, and was his very strong proof, or very strong evidence, that Venus and therefore some other planets were actually in orbit round the sun rather than the Earth, because he observed, as we can do, the size of Venus changing and the size increasing as the phase reduces, as it moves round towards inferior conjunction when it's between the Earth and the sun. And that's what will be happening over the next few weeks.
That's good. That's quite a pretty image. And I was looking at Venus earlier on this evening, really high up in the sky. And I'm sure a lot of people have noticed it who never usually look at the sky. And I was interested to see if I could see the phase with binoculars. Now, I've got several pairs of binoculars. The one where I could definitely see the phase was 15 by 70 binoculars, 15 magnification binoculars. And the phase was quite clear in those. It wasn't a huge image, but it could certainly be seen. And I think that if I'd looked earlier in the evening, when the planet wasn't so bright, when it was just visible in twilight, I could have probably seen the phase with 10 by 30 binoculars. So for all of those of you who haven't seen the phase of Venus, have a look with binoculars and keep watching it as it sinks towards the sun over the next into the sunset over the next few weeks, and you will be able to see the phase, I'm sure of it. Well, that's wonderful. Thanks very much, David. And we've got another David coming along later on. And now I'd like to move over to Chris Hooker, who's in Chelmsford, I think, sorry, Oxfordshire, beg your pardon. And you have got the moon in your 10-inch.
I
do, yes. Let me just
Yep.
share my screen.
10-inch Newtonian telescope, which is a reflecting telescope.
Right, I hope you can all see that.
That's a great image.
Right, so I thought what we'd do this evening is a little tour of what we can see on the moon there. Starting with these two craters, which are more or less in the middle of the image. They are called Hercules and Atlas. Hercules is 70 kilometers in diameter. Atlas is about 88 kilometers. The thing about craters on the moon is that nowadays they all look quite different, or a lot of them do. When they were formed by impacts of large lumps of rock smashing into the moon, they all start out more or less the same, with some variations depending on the size. But over the 3.5 billion years that have elapsed since the craters were formed, they've been modified in various ways. And some of them have almost been completely filled by lava from inside the moon. Others have had later impacts modifying the shape and so on. And some of them are more or less as they were at the time. So you can see, for example, Hercules here has a flat floor with another crater in it. But a crater that size would normally have a mountain peak in the middle. And Hercules has been flooded with lava from inside the moon, and the mountain peak has been almost completely submerged. If you look very carefully, there is a little hummock about a couple of 100 meters high in the middle, and that's all that's left of that mountain. But other craters have other modifications, and we'll come on to that as we go down. Now, this is moving south. This image is the way up you will see the moon if you look at it yourself tonight. So what we have here is another rather larger crater. This is called Posidonius, and that is nearly 100 kilometers across. I'm just going to crank up the brightness a little bit to make that easier to see. There we go. Now, this is a crater that would normally have a large mountain peak in the center. There is a little bit of something, but it's been changed dramatically by the intrusion of lava into the middle. And then a great slab of it has been lifted up on this side by something from within the moon pushing it up. And there's also a large number of cracks on the center of this. This is what's called a floor fractured crater. There are a few examples of these on the moon. This is one of the nicest ones. And it's very impressive. The floor of this is slightly higher than the areas outside here. There's about a 300-meter step. If you were out here, you'd have to climb up 300 meters through that little gap to get onto the floor of Posidonius. So that's another type of modification of craters. Now, next to it, you can also see this kind of sinuous shape on the otherwise flat surface of, this is Mare Serenitatis, Sea of Serenity. And this is sometimes known as the Serpentine Ridge, because it looks a bit like a snake. And this is what's known as a wrinkle ridge. This is where, again, lava was flooding this basin. This is a large impact basin, a very old one. Lava was flooding this, and the lava that was coming in from somewhere in the middle was running into other obstructions. And so it kind of piled up. Lava is fairly viscous, and it piled up into this ridge, which is between 200 and 400 meters high in various places. And you can only see it when the sunlight is at a very low angle, because it's only a few hundred meters high. If the sun got up another 10 degrees, that would disappear completely. But when the sun is low like this, you get a really nice view of it. So that's another of the kind of features we see on the moon. Let's move a bit further south. And we get down here. Now we're getting to the point now, which is as a famous piece of history here. This area here, southern end of the Sea of Tranquility, is where the Apollo 11 mission landed in 1969. It's somewhere around where my pointer is there. Don't know exactly. There are 3 small craters around here called Armstrong, Aldrin, and Collins, after the 3 astronauts from that mission. But that's where they landed. It's a nice, safe place on the moon. It's near the lunar equator, so they were in good contact with Earth the whole time. And the first mission, they didn't want to take any risks. They found a nice flat area, touched down, collected some samples, and then came back again. Another lunar mission, get back up again actually, the Apollo 17 mission, which was the last mission to the moon, landed in this area here. And you can't actually see at the moment. There is, in this region here, around these mountains, there is a blanket of volcanic material, which looks darker. And when you see this at full moon, you can clearly see it's a darker area just in this region here. And the reason they went to that was to try and collect some of that volcanic material, which had come from deeper inside the moon. Previous missions had collected materials from the surface. But this area, because of the volcanic activity, was felt that it would have some material from further down, and it would be really interesting to get a sample of that and bring that back to Earth. And they succeeded in doing that. That's what they did when they landed there. So let's go down here. Now, there's a couple of interesting craters here, which will crank up the brightness. The names of craters on the moon are often very historical. They're named after famous philosophers or historical figures like that. There are something like 16 or 1700 named craters, and only 33 of them are named after women. And this one here is one of them. This ring feature here is called Hypatia. And Hypatia was a Greek lady who lived in the city of Alexandria in about the 4th century. She was a mathematician, and her father was a mathematician, and she contributed to some of his work. The other crater that we can see here, which is named after a woman, is this one. This is called Caterina, and after Saint Catherine, who was, again, another figure in the sort of Mediterranean area. She too lived in the city of Alexandria, and that is the crater that's named after her. This crater up here, the one with the prominent mountain, is called Theophilus, and that's obviously named after Greek philosophers. Sorry, trying to get it centered. This is interesting. You can see from this one that it overlaps this crater. This is called Cyrillus. These are all about the same size. That's 101, that's 90 something, and Caterina is 100 or so kilometers. Theophilus is the deepest crater on the moon. If you were standing on this rim here, the floor of Theophilus would be about 4.5 kilometers below you. And there are other craters that are sort of three kilometers, but Theophilus is the biggest one. And the mountain in the center rises about 2.5 kilometers from the floor of the crater. So Theophilus is one that has not really been altered very much since it was formed. It does have a flat floor, but that was due to the melted material that occurred when the object hit the moon and formed the crater in the first place. With a large impact like this, there's a lot of melting. The moon gets depressed, the force pushes the moon down, and then it rebounds, and that's why you get the peak in the middle. And this peak is, as it was pretty much 3.5 billion years ago, subject to minor modifications due to later impacts. But that is a very impressive crater, and these three clearly seen at this time. And as I say, Theophilus is the deepest crater on the moon. Now, this area it's just in the middle there, is the Mare Nectaris, or Sea of Nectar. None of these are actually seas, of course. They were named that because the people who gave them the names thought they were seas of water, but obviously they're not. We know now they are plains of lava. These are old, large impacts which have been filled in by lava coming up from the center of the moon. And this crater, this horseshoe shape here called Fracastorius, you can see is right on the edge of this basin, and it was clearly formed after the basin, but before it got flooded with lava. because the lava came up in the middle and flooded the edge of Fracastorius and filled it more or less completely and left just this horseshoe where the inside here is lower than the outer part. And that
Yes, I've
makes
heard about this lunar cross that it's in this area of the moon. Can you just tell us something about the lunar cross? Is it visible at the moment?
I'm actually not sure what that is.
No,
Sorry, you've caught me out. You've caught me out there. I don't know what that is, I'm afraid.
It's a part of a feature. I'm not sure if we've got the Altai Scarp there.
Yes, that's what I was just about to talk about.
I suspect is part of it. I think we need to move on pretty shortly, actually, because we've got lots of it's what's known as the clair obscure effect, which is brightness and dark parts of the moon all combining to form a cross. To be honest, something I've not seen, but people who are keen on finding these patterns do talk about that. You're using a 10-inch Newtonian telescope, isn't that right?
10-inch Newtonian telescope, yes. With
yes,
I'm actually magnifying the image three times from that in order to get a decent image scale. You can see there's a bit of shimmer, which is due to the atmosphere, as we've talked about before. But
well, I think that's a really lovely view of the moon, and thanks very much for talking us through the formation of craters, which it's an amazing sight to see. I'd like to move on now to Mark, actually, who is up in Edinburgh. But your scope, Mark, tell us about what you've got. You've got something very different for us. This is the nebula M42, the Orion Nebula, and your telescope is in Spain. Is that right?
That's right. Yeah, I'm in wet and windy Edinburgh, but the telescope we're fortunate to have is the Astronomical Society of Edinburgh's telescope in Spain, and that's a live picture you can see of it there with a nice view of the sky. You can actually see the Milky Way going overhead to the left there. But what I've got the telescope trained on is the Orion Nebula, which is probably one of the most famous sights in the night sky. And this is it live now. It's looping at 5-second exposures, and it's looking very dramatic as it always does. This is using a mono black and white camera, which maybe doesn't look as interesting as color, but it does have some very interesting effects that we can use. For a start, a lot of the Orion Nebula is actually hydrogen, sorry. So we can actually look at the Orion Nebula in different filters. So if I were to switch the filter we're using to a hydrogen alpha one, and we can actually see what the Orion Nebula looks like at a different wavelength.
I can see a satellite moving up in the top top left-hand corner of the screen, and that's quite common when looking at the Orion Nebula, isn't it? Because it's in the light. That would be a geostationary satellite, I guess.
Potentially, yes, and of course we're not short of satellites these days, are we? So as you can see, the look of the Orion Nebula is quite different now. The stars have been reduced quite dramatically; they're not as bloated, and the nebulosity is actually quite a lot sharper. And of course, we get another satellite just to prove the point, which we have a large number as well. So with this telescope, it's really useful for that. We can obviously photograph it in red, green, and blue filters as well and make a nice color image. But we also have these narrowband filters, which give us a nice, interesting effect. One of the things that the Orion Nebula is famous for and interesting about is at the heart of it is something called the trapezium. Right there in the very center are 4 stars that are very close together, very hot and very young. This is one of the main areas of star forming in the region, and these stars are very young. It's very hard to make them out there, but if I turn off the stretching, hopefully we can actually just about make them out. Yes, we can. So that is the trapezium, which is a well-known little cluster of stars, and very interesting to see. And I think a lot of the glow from the hydrogen is actually caused by them exciting the gas in that region. On this telescope, we also have another telescope side by side, which is a wider field one. And if I bring that up here, it's got a color camera on it, and there you can see it's not exactly aligned to the center of the Orion Nebula, but it's a much larger field of view, and it gives us a nice color image as well. So if I loop that, then what I can actually do is to start to build up a nicer picture of that by doing some live stacking.
So tell me how this picture has been obtained. It's using your camera on the telescope, but it is a live image, isn't it?
It is a live image. It's looping at 10-second exposures. So what I'm going to do now is actually start stacking those images as they come in. And this is hopefully going to do that now. There we go. So the colors are a little bit strange, but that's always the case with live stacking. And as these images are coming in, this program, SharpCap, is actually starting to put them one on the other and getting rid of a lot of the noise. If we go back briefly to the individual images here, you can see there's quite a lot of noise in that image, but the signal is there. But the more frames we take, the more frames we stack, we get a better signal to noise ratio, and that is precisely what this is doing. So as it builds up, it becomes a much nicer image, and we can start to play around with the levels and things like that, and the colors as well.
And whereabouts is the telescope, in fact, and how do you manage to control it over this distance?
Well, it's in northern Spain. If I go back to the image of the telescope, I'm in the wrong frame there. Yeah, northern Spain. It's all over the internet, so it's very, very easy to control. It's got a nice network bandwidth there, and if I just go back to here, we can see there are actually quite a lot of other telescopes in the area as well in this observatory. That's our telescope right at the back there. It's one of the bigger ones in the observatory, and you get a nice view of the night sky. And we can control rolling the roof off as well. So if the cloud watcher says it's clear, it's dry, it's dark enough, and it's not too windy, then I can send the roof off. But I can't actually close it again. So the only way the roof ever gets closed is if it becomes too light or unsafe, and that means it stays open all night long. But it's quite an interesting way of running things. You can't just pop out and plug something in and out because it's miles away, but you could do an awful lot of stuff at that distance.
One thing I've been asked on the questions here is this lady Nina. Who's Nina, or what does she do?
Nina is night sky imaging and astronomy is what it's short for, and it's what a lot of us are now using. It's a free piece of software, and it's really rather neat, and it controls the equipment. So on here we have our camera, a filter wheel, a focuser, the telescope mount, an autoguider, a flat panel, and we can control the roof as well, and there's a safety monitor tied in as well. So we can do everything from Nina. It's an amazing piece of software, and of course we can take pictures here. So I can do automatic focusing, but I can do things like just changing the filter that is taking an image through simply by doing that. So all very integrated and very neat.
Well, that's absolutely great, Mark. Thanks very much indeed. And there's some lovely pictures there of the Orion Nebula. We may come back to the Orion Nebula later on. Now I'd like to move back to England and to David Arditi in Edgware, who I think has got the planet Jupiter up for us. Let's have a look. I think you're muted, David. But I can see a satellite on the disk there while David's unmuting himself. There you go. You're unmuted now. No, you're not. So we can see the whole disk of Jupiter there. No great red spot that I can see. That's around the other side. But we've got a satellite shadow there on the disk. I'm guessing that's Io. I'm not sure which satellite that is that's casting that shadow.
Yes, I've just researched it. I believe it's Io. Io is actually on the disk at the moment, but it's almost invisible because it's a very low contrast against the North Equatorial Belt. The North Equatorial Belt is in the lower part of the image, is that thick brick-coloured belt running across the planet. and Io is also a brick color, and Io is just to the lower left of its shadow. It's just to the right of the middle of Jupiter, so you may just about be able to pick that up, but it's difficult to see the planet itself against the rather similar color atmospheric belt of Jupiter. And this shadow transit will take some hours, and they're quite common. Occasionally you can get shadows of 2 or even 3 of the moons on Jupiter at once. We're talking about the 4 main moons, of course, the so-called Galilean moons, Io, Europa, Ganymede, and Callisto. And they have orbits around Jupiter which are synchronized and are complicated clockwork. They each go round a certain number of times. They're in certain harmonic ratios with respect to one another. So it's fascinating to follow these, and you can see these shadows in very small telescopes because it's such a high contrast thing. You probably not in binoculars. Binoculars wouldn't magnify enough, but you can see the moons themselves in binoculars, of course, particularly if you manage to mount the binoculars on a tripod, so so you can keep it all steady.
Yeah, that's a very good point, that you can actually see these satellites moving around, not as well, you actually almost can in real time through a telescope, particularly the closer in ones like Io and Europa. If they're moving past each other, just a matter of a few minutes will show you the difference. And sometimes you will be looking at Jupiter and only see 3 satellites, and then a minute or so later you'll see the 4th, which has suddenly appeared. Now, I'd like to move over to Martin Bracken, who's actually got a time lapse, which he did of Jupiter, which actually shows the satellites in motion. So, and it is Martin who's in Chelmsford. So, over to you, Martin.
Thanks, Robin. Yeah, I have a small time lapse here, which I shall just share with you. If I can just go from that one. Okay. So, can you see that?
Yes.
Right. Okay. So this is a 3-hour time lapse, which I've taken over 3 hours and condensed it all down into 36 seconds. And you can see Io here transversing the planet, and very shortly you'll see the shadow of Io just join. And as that moves across the planet, it basically, as David was saying, disappears into the belt. You can't really see any detail on it. But this was taken with a very small telescope. You can also see Ganymede now just popping around the corner, photobombing the image. And that disappeared into Jupiter's shadow almost immediately. So it's quite amazing the speed at which Jupiter actually does rotate. I mean, given the fact that the day's length on Jupiter is just 10 hours, and being the size that it is, that many times bigger than Earth, is quite amazing. It's the fastest spinning planet in our solar system, and it's actually got 92 moons, which I found out only today, 12 of which were discovered in 2023. So there's probably more than that, but they just haven't discovered them all yet. But yeah, I just thought you might like to see this time.
Yeah, that's great. And I love the way Ganymede just disappears, goes into Jupiter's shadow.
It really is interesting the way that the shadow of the planet just disappears, doesn't it?
Yes, I wasn't expecting to see that. That's amazing. Actually, the record for number of satellites is currently held by Saturn, which has got 143, which is amazing. But then Saturn is a very strange planet anyway, with all those rings. So the extra satellites are probably connected with the fact that it's got rings as well. So Jupiter, 92, I think you said. It's,
yeah. The current count, I think, is 92. Yeah.
And they seem to be being discovered every year. As at the moment, there is a satellite going around Jupiter called Juno, isn't there? So I think that's helping to discover them. Well, that's super. Thank you very much, Mark. And now we go back to some deep sky stuff. I think we've got Dave Eagle in Northamptonshire, And you've got some deep
Robbie?
sky stuff lined up for us. Is that
I
right?
have, yes. I've got one telescope on. I need to share screen, but it's not letting me at the moment. So I've got one scope set up on one of the clusters in the double cluster. Let's see if that'll share now. Yes, it will. Okay, so there we go. So we've got double cluster, one of the part of the double cluster there. You can see the bright stars in there. But if you look really carefully, I'll get rid of all the rest of the things on the screen. There are some really nice red stars in there. Because the stars give you information about how hot a star is. So a white star is much hotter than, say, a red star. And you can see there's you can see at least 3 orangey red stars nestled within the cluster because they're quite old clusters. And this is what we call an open cluster because there's lots of space between the stars.
They call it the double cluster, and that's because there's another one next door to it. And
There's
we're talking
another
about what people can see with binoculars. That's a prime target, isn't it?
It is, and it's almost overhead at the moment. So if you've got a pair of binoculars, go outside, look overhead with the binoculars, and you'll probably see these clusters. And if we go
And if
to
you
the
know where
map,
Cassiopeia is, it's in between Cassiopeia and
yeah, if we
Perseus.
go to the map here, you can see the double cluster. So there's the one we're looking at there. There's the other one there. And if we zoom out on the map, you'll be able to see Cassiopeia is here. Okay, so you've got the
W shape.
Cassiopeia there, and if you draw a line from the middle star across here and go just over the distance, and that's where the double cluster is. What
instrument are you using to look at this?
This is with a 5-inch refractor. This is a 5-inch refractor.
So that's live stacking with a 5-inch
That's live
refractor.
stacking at the moment. It's getting a bit
Yes.
hazy here. And when I go to the next object I've got lined up for you, you can see that quite nicely, or not as nicely. And again, it's another nice open cluster, and it is the Pleiades. So I've got that on a different device here, and you can see it's looking very hazy. There is nebulosity around the Pleiades star cluster,
But not as much as that.
but not as much as that. Yeah, I've got some haze coming in now, so it's definitely getting worse as we go. But you know, if you want to catch that and say, look, I've captured the nebulosity around the Pleiades, then you know you can claim that, I guess. But the dust that they're going through wasn't the dust that the stars were born from. They just happen to be passing through that gas and dust as they go.
Certainly, when I was a kid, the textbooks all said that it's formed out of the gas and dust that it's passing through. But actually, there's virtually no gas there. It's all dust because it's actually a blue color. And that's the color of dust, the reflection of starlight on the dust. Yeah.
And the stars are very hot as well. So, yeah, so it's quite a young cluster too. And the other object I've got set up on is it going even further away, so nearly 2.5 million light years, is the Andromeda Galaxy. So this is the C star that I've got on there. You can just about see the dust lane starting to come out there. But again, as it's progressed, the haze that's coming in is ruining the view. So
that's not that's a sort of image that you might get through quite a large telescope. In fact, if people say, oh, I'd love a really big telescope and I could see all the colors and the spiral arms of galaxies, actually it's not all that easy, because I've looked through some pretty large telescopes from dark skies, and on the Andromeda Galaxy you don't get much more than that yet. Oh, what's gone wrong there?
I'm just reshuffling things. I've just put it on so you can get a better view of
that. That's good.
And it upsets the other screens. That's the problem.
Because that dust lane, there are a couple of dust lanes visible on that, and that's about what you do see through a large telescope. So I must say, if you're into astronomy, don't expect that you will see something fantastic and colourful through a large telescope. There's a great deal of things to be seen, but the colors and so on that you get in photographs aren't one of them. It's a bit like the aurora. Everybody has been talking about the aurora and the northern lights, and people have been out and say, well, I couldn't see very much color. That's because it's the camera that picks up the color, unless it's a very bright one. If you go up to Norway or Iceland, then you often can see color, and you can in this country as well. I saw that back in October. I saw some colors, but they were a bit muted compared with the camera view. So that, as you see on these pictures, you don't get too much color until you use a camera.
I used to have a 14-inch Dobsonian, and when I used to look at the Andromeda Galaxy, you used to see that one side of it was sharply cut off, which is the bit you're seeing at the top there, just near the central nucleus. And then you perhaps saw a little brightening after that. And then on the other side, which is towards the bottom, you could see that the brightness just gradually dropped and didn't have that sharp cut off. So you could see the dust lanes, but not, not as much as you would think you would, because this is the sort of thing that definitely comes out much better in photographs.
Now, I believe that Mark has, with the telescope in Spain, has got a picture of another galaxy, M81. Perhaps we could go over and have a word with Mark now. Thanks very much, Dave.
Okay.
Yep, I've moved on to another galaxy here. I'll just bring that up. So M81 is about 12 million light years away, is that right? A very nice grand design spiral. And this is live again. These are 20-second exposures I'm taking here, but it's really quite an impressive galaxy. And you can see lots of dust lanes in there as well. It's not as big in our night sky as Andromeda, but it's still pretty large. I'm not quite sure how big it is. But yeah, it's about about the same size as the full moon across in the sky, but obviously quite a lot fainter. And I've been saving some of these images just now as it's coming up live, and we can do some live stacking on that, hopefully, as it comes in. Yeah, and there it is, stacking all the images we've just picked up, and definitely one of my favorite galaxies, this one, and something I actually studied at university as well. It's always been, I studied in university quite a long time ago, and the images we could get with a much larger telescope then don't come anywhere close to the sort of images that we can get today with relatively small telescopes in comparison. And that's down to the technology and largely to the software and the techniques as well. But it's quite an amazing thing that we can actually gather this sort of data today from our back gardens, or from Spain in this case.
Yes, and in fact, you can get an equivalent image from your back garden, no matter almost where you are. Perhaps not quite in the middle of London, but I've seen some pretty impressive images of even of galaxies from the suburbs of London, which look not too dissimilar from that. They take a lot longer to accumulate, but with modern processing techniques, you can actually get some pretty decent image. And those C-star telescopes that Dave Eagle was talking about, the ones he was using there, are pretty cheap. I mean, everybody thinks you need a lot of money to buy a telescope that will show pictures like the one you're showing there, but the C-star costs of the order of £500, and it's pretty automatic. So it's, in a way, people say, well, it's cheating. You might as well just buy a photograph of the thing. But I think it's still fun to put that little telescope out in your back garden, and in 10 minutes it will have created a photograph, maybe not as sharp as the one you've got there through a large telescope, but nevertheless pretty good. But it always goes to show that a good big telescope will beat a good little telescope any day. So
yeah, resolution is everything, isn't it, really? But no,
yes.
The stars are amazing. We have, I don't know, we have about 20 or 30 in our society now. They are so popular, really amazing.
Yes, and the people with them are very evangelical about them and how good they are. But £500 may seem a lot for a telescope, but otherwise you're into thousands of that. Oh, now we've got M81 and M82. Tell us about that.
Yeah, well, these they are a pair in the sky, and the large telescope can't fit them both into the field of view, but this wide field refractor can. It's not as good quality because the galaxies are smaller, but M82 is a very interesting one. You can't quite make it out. Well, you can just about, but This is called Starburst Galaxy, and there's some amazing red lines of flux coming out of there. Lots of star formation going on in that galaxy, and if you take longer exposures and stack the frames together, you can get some amazing detail on those flux lines there. But again, a very popular galaxy to image for amateurs.
That's super. Now I'm going to, if you'd like to stop sharing your screen now, let me. All right, sorry, I've just got a video to show you myself. Let me stop its playing at the moment so I can show you from the start. Of course, when you're doing this sort of thing, everything runs quicker than you want it to. Oh, there's the window I'm looking for. Right, hold on. Let me stop that and I'll start it again. Last night I went out and I found the planet Uranus. Now, a lot of people have never seen the planet Uranus, but it's actually very easy to find at the moment. And so I thought I would do a video showing you just what it looks like. And so I'm going to share my screen if I can and find the right window. There we go. Let's have a look at this. So this is how to find the planet Uranus. Oh, did I do it with sound? Let me just check. I'll stop share again. Sometimes the sound doesn't come on unless you do it properly. Things have gone all haywire on my screen. It's that's one of the things. So it seems to be able to get it up at all. Tell you what, let's move on, and I'll do that a bit later. So let's go back to David, please. And he's in Edgeware while I'm sorting out my Zoom problems. And David, I think you've got Mars for us.
I have indeed, Robin. The red planet is rising in the southeast now. It's just past our position, and it's rapidly moving away from the Earth. And you can see here the image through my 14-inch Schmidt-Cassegrain telescope located in the outskirts of London. So this is an image with south at the top, as usual. We've got some albedo markings visible. Those are the darker patches, which represent darker soils on Mars. The part at the top, the darker patch at the top, is the Solus Lacus area, and then there's another dark patch to the left, and that is Aurorae Sinus. Then you can see at the bottom of the disk the bright white South Polar Cap, which is made of ice, water ice, and carbon dioxide ice. And it is shrinking at the moment. It is northern spring on Mars. It's reasonably good seeing. It's a reasonably steady image, and I've been regularly imaging Mars. I'll maybe I can show you one that I took yesterday. I haven't got it up at the moment. I'll find it in a moment. What else is there to say about Mars, Robin?
Well, we've got what is called the eye of Mars on the screen there. Can you just point that out, Solus Lacus?
It is there.
Yeah, it doesn't look much like an eye on this rather blurry image at the moment, but when you've got the sharpened up image, it does actually have a sort of eye-like appearance with a sort of circular area and a central area, a central blob. One thing that people often wonder about is the canals on Mars, and since it's now well understood that the canals on Mars were merely an optical effect. They don't appear on photographs. However, there is a long straight feature on Mars which is called the Valles Marineris. A lot of people have seen pictures of that, a great long canyon, many times longer than the Grand Canyon, but it is pretty well in the center of the field of view at the moment. And of course, there's no sign of it because it just doesn't appear up on photographs. You've really got to be there to see it. It's filled with sunlight at the moment. It's right in the middle of the disk, and there's just nothing to be seen of it.
Indeed, yes. The occasions on which we can see Valles Marineris is when it fills with dust, which sometimes happens. You get dust storms on Mars, and that area is frequently a source of dust storms. And they go to a lower level. The dust sinks to a lower level, so it sinks into the valley. And sometimes on some very good amateur images, you can actually see Valles Marineris through the different color of dust that it has in it. And these are albedo features on Mars. They vary from year to year, from opposition to opposition, because the winds in the thin Martian atmosphere blow the dust around all the time. And so the features do look slightly different to how they did in images and drawings made in past decades and past centuries. It was a famous observer called Antoniadi, observing with the really big refracting telescope at the Paris Observatory, their 33-inch refractor in Meudon, who disproved the canals argument during a very, very good opposition about 1910, when Mars was particularly close to the Earth. And he did some splendid drawings which showed the features as we know them, really, and didn't show the canals. But it took a long time for the canals to disappear from charts, even charts that NASA was using in the early stages of planning the first probes to Mars in the late 1960s. Even some of those were still showing these completely discredited canal features. I'll show you an image of Mars taken last night. There it is. And so here the Solus Lacus is this feature on the upper left. Mars is rotated round a bit to the left compared to the live view that we were looking at. And Solus Lacus has this dark core and then this also dark rim to it. And this image also, you can just about see the volcanoes, not directly, but you can see them because they're a lighter color. The biggest volcano in the solar system, Olympus Mons, is right in the center of the disk, just below the center of the disk, and there's like a lighter triangle surrounding it. And the lighter triangle is the vast area of lava flow around Olympus Mons. Olympus Mons is about 20 miles high, and it is vast. It is if it's so big that if you were standing on its slopes, you wouldn't be able to see the top of it, because the curvature of the whole planet would take it below your horizon. And there are several other big volcanoes, all extinct, of course, on Mars, known as the Tarsis volcanoes, Tarsis Mons, Ascraeus Mons, and the other one, whatever the other one was called. And they are a bit to the left of the center of this image, and they're marked by slightly lighter patches, which may be cloud. Maybe you get what are called orographic clouds on Mars, which is a phenomenon you get in the Earth's atmosphere when the wind blows over higher ground and the air goes up, it cools down, moisture comes out of it, and you get clouds over mountains. And you get the same thing on Mars, and we can actually see that with amateur telescopes.
David, thanks very much indeed for showing us Mars there. That's a beautiful image. If you could just stop sharing, I'll see if I can sort out my share now. Share sound, that's what I was looking for before I did it. Now let's go over to my Windows Media Player, which I hope I can play. There we go. Can you see that? Can someone just confirm that they can see that now?
Not yet, no.
Oh, right. Okay, I'll go back again.
Yes, it is coming.
Right. Okay, let's play it now. I'm going to show you how to find the planet Uranus in National Astronomy Week 2025. And we start by looking high up and looking for the very bright planet Jupiter. You really can't miss it. It is the brightest thing in the sky apart from the moon, and it's just above that V shape of stars which we call the Hyades star cluster. But a more famous star cluster is just a bit over to the right, that one there, and that's the cluster known as the Pleiades, or Seven Sisters. Count them, there's many more than 7 of them, and I'm using at the moment a lens which gives you the same sort of field of view as you would get with typical binoculars. Probably not quite, but getting on for anyway. And you can see roughly the same number of stars in a reasonable sky. So what I want you to do is to find the Seven Sisters, which you can find even in city skies once you've found Jupiter with the naked eye. But to find Uranus, you will need binoculars, because Uranus is just a little bit too faint to see, even in country skies, and particularly from town skies. So having got the Seven Sisters, you need to move down a bit until you see that little pattern of 3 stars I've got underneath there. Then down a bit more, as we have here. Now you'll see the 3 stars and 2 stars to their lower right, and if you go below those 3 stars and to the left a bit and level with the lower and brighter of those 2 stars to the right, you'll see another little dot, which is actually the planet Uranus. I know it looks just like a star. Even in a fairly small telescope it still looks like a star, but you need a fairly good magnification of maybe 100 or so to see that it's actually a planet. And for thousands of years it was regarded as just another star. Nobody paid any attention to it, and it wasn't until Sir William Herschel, or he was just plain William Herschel at that time, discovered in 1781 this object through his telescope from the back garden of his house in Bath in Somerset. And he noticed that it wasn't just a star, but it had a bit of a disk to it. At first he thought it was a comet, but when it was studied for a while and realized that it didn't move in the sort of orbit that a comet does, it was realized that it was the first planet ever to be discovered, and all the other planets that up out to Saturn have been known from prehistoric times, but nobody had noticed this little faint star just to the limit of naked eye visibility, which actually moved through the sky. And you can't blame them, it's very inconspicuous, and that turned out to be the planet Uranus, and that's how to find it in the sky. So there you are. I will be putting that video onto the NAW website, astronomyweek.org.uk, very shortly. So I hope a lot of people would be able to go out and find the planet Uranus. Now we're going to go back to Mark in Edinburgh, or rather with the telescope in Spain, because I believe you've got a colour view of the Andromeda Galaxy.
Yes, I have. I just moved on to that. I'm using the wide field telescope, which hopefully you can see there. And this is live again. These are taking exposures continuously, so I can live stack that again and see what that looks like. And there we go. That's actually been building up as we've been doing that. So it's about 35, 36 frames on that, and we can see it's actually building up quite a lot of detail. As well as the main galaxy, you can see the 2 satellite galaxies, M31 and M110 there as well. And the dust lanes are standing out really quite nicely. So again, always an impressive thing. I think the focus has drifted over the last hour, so we need to autofocus the telescope because the stars are getting slightly blobbier. But yeah, there you go.
You can certainly see the spiral arms much better there. You can really tell that it's a spiral galaxy. And M31, of course, is a galaxy which was really crucial in understanding the distance scale of the universe, because it's close enough that back about 100 years ago, it was possible to see individual stars. You might think that there are plenty of stars visible there, but all the stars you can see on that picture are actually in our own galaxy, and we're looking out through them. It takes a pretty large telescope to see individual stars in the Milky Way and in the Andromeda Galaxy, and they have to be pretty bright stars. But there are certain variable stars called Cepheid variables whose brightness varies with the whose variability varies with the brightness, and so you can if you can see the period at which it varies, you can tell how bright it really is. And that was made it possible to measure the actual distance to the Andromeda Galaxy, and it turned out to be much farther than people realized. It was well outside our own galaxy. To start with, people thought that these things might have been solar systems in the course of formation. The chap who did that piece of work you've probably heard of. It's called Edwin Hubble. So that's why we've got the Hubble Space Telescope, and why it's named after him. He really established the distance scale of the universe. Well, that's a smashing view. Thanks very much, Mark. And that's coming to us live from Spain now, isn't it?
It is, yes. Yes, it is, yeah.
There's one thing I'd like to mention for those of you who are variable star observers, incidentally, and that is the star Algol. We saw earlier on a quick view of Perseus. I don't have one to hand at the moment, but those of you who know the sky, look at the star Algol in Perseus, because round about now, in fact, it's almost at its minimum. Now, if you can look at Algol tonight and then look at it again tomorrow night, you will see that it's brightened up considerably. It's gone through one of its minimums, and it's considerably darker, dimmer at the moment than it would be at any other time. We've got a few minutes left, so I'd like to call upon Andy DeVee, who's in Spain as well, and you've got a little bit of stuff to tell us about your solar observing.
Yeah,
so that's something we haven't looked at tonight for obvious reasons. So if you could just give it 2 or 3 minutes on solar observing, please.
Okay. Can you see that okay?
Yep.
Just showing you a time lapse there of a sunspot, which for AR 3363, and that's a 2-hour 20-minute run. And you can see all the convection cells boiling. These are about 1,000 kilometers in diameter. You've got the dark umbral area and the penumbra, and you can see the plasma running down the fibrils actually into it. So that's in white light. So this next one is a CME, so it was a large prominence that erupted. As you can see from there, I'm imaging for about 1 hour and 15 minutes, and I've overexposed the surface of the sun so that to brighten the prominence, but you can also see the spicules along the surface as they jump out. This next one, these are what we call post-flare loops that I've captured, and these are magnetic reconnections, or reconnection feature, and the plasma runs down both sides of the arc simultaneously. And this was following only a very small M1 class flare during June last year, and it was the duration that caused the magnetic reconnections.
So the CME means coronal mass ejection, and
Correct,
that's
that's
a particular
right.
interest, because when there is a coronal mass ejection, it takes place on the center of the sun, like that big sunspot you showed. There is a good chance that we would get an aurora in the next few next 48 hours or so. And I gather there have been some aurora events on the sun recently.
Yes. This is one from May last year, and this is one that caused all the it were a G5 storm, and we actually got auroras over my location in southern Spain. But this was the actual flare, and I caught the whole sequence of this X2.2 plus flare. But you can see all the magnetic reconnection loops. Can you see them down there, which follow the event?
Yeah.
Now this flare is as big as Jupiter, just to give you an idea of scale. So,
and the flare is not one of the prominences, the sort of hydrogen flames that would appear.
No. The surface temperature is generally about 6,000 centigrade, but when the magnetic field breaks and reconnects, that's where you get a flare, and the temperatures go up to about 2 million degrees. This next one shows you another X-class flare I caught in September last year, and that was a very short duration X1, and you see a brightening of the flare there, followed by the reconnection loops. And then the last one I'll show you, this followed an 1.8 class flare from 26th of October. I just missed the main event, but I was able to capture all the reconnection loops here along the surface. And normally you don't pick them out on the surface so well, but this particular one, it caused quite a good feature.
These are the ones which, if you saw them on the edge of the sun, would actually appear in those
like arcs, yeah.
Like
And
arcs,
then
yes.
I'm just showing you here, this is only a small C-class flare, but when you go high resolution, you never know what you're going to pick up. And there's some real nice plasma trails. Can you see running down all invisible loops here above this? And you just see the C-class flare break, and it actually runs along that filament and impacts in this area here. And then you've got quite a big filament here. But
Yeah.
these are done with time lapse, and I always put the date and universal time for context, and normally I present them in the normal solar orientation. So I'll pass it over back to you now, Robin.
Right. Thank you very much for finishing on a high note there. That's really spectacular.
A warm note.
Yes, a warm note. So, of course, you don't have to be in Spain to see the sun like that, but the equipment for getting it, for doing those very narrow band images of showing those hydrogen features is available to all, but you do need to
take
to
extreme
spend a bit of money.
precautions. Yeah, they're expensive, but always follow the normal precautions when planning to image the sun.
Yes, and don't just look at the sun and expect to see them. You won't, and you'll just actually blind yourself. Well,
Yeah.
thanks very much, Andy. And for everybody else, we've had Dave, Chris, Mark, Martin, and David, and Andy, who I missed out. That's a wonderful show. We've seen a wide variety of objects from literally just over our heads. We've also all 1 to 2 satellites, the moon, and all the planets apart from Saturn so far, and we've gone out as far as the distant galaxies M81 and M82. So thanks to everybody, and tomorrow night we will be back again, and we'll show you the same planets, of course, and see how they're rotating and see new features on them, and we'll look at some deep sky objects as well. So with that, thanks for watching, and we look forward to seeing you tomorrow. Good night.